Hi, welcome to Future Fast. And for those of you who are here for the first time, welcome to Future Fast. You made a great choice to have a peep into the future. And today we have a very interesting guest, like always. So I urge you to first subscribe to Future Fast and also do go back and look around. We have all kinds of interesting conversations, mostly science. And great people, and also some very interesting predictions as well. And getting on to today's guest, we have Chandrasekhar Arcot. I do know him for a very long time, but I guess we'll get into that conversation. Chandra is based in Bangalore. He's the co-founder and CTO of Axiom Consulting. He possesses a deep expertise in automotive design, simulation, machine learning, computer vision, and deep learning. And these things before they became popular like today. And under his leadership, Axiom transitioned from a primary focus on automotive product development to explore diverse industry verticals. He was instrumental in building a global technology team and establishing strategic collaborations with industry leaders. At Altair Engineering, Chandra played a pivotal role in setting up offshore CAE consulting units, emphasizing automotive design and simulation. Earlier in his career with Tata Consulting Services, he spearheaded R&D initiatives in gas turbine CAE process automation as well. Academically, he holds an MTech from NIT Karnataka and a BE from MSRIT, Bangalore. He has received 4 US patents related to transit instrumentation and modeling and has also contributed to several technical publications. He is an active mentor to emerging startups through several accelerator programs, including Ginserve, Stanford Seed, and others. With that, Chandra, welcome to Future Fast.
Thank you, Nanjunda. Thank you for the opportunity to be interacting with you on this very interesting podcast.
Well, my pleasure. Thank you for making time. So, Chandra, can you please take us through your journey share your journey with our listeners and audience, starting from as usual, a software engineer to entrepreneur, and particularly, getting into the product engineering space.
Yeah, thank you. I started my career with TCS. This was in the mid-90s, I would say, about 94, 95 times. And this is even though it did bit of software engineering, it's a lot to do with mechanical engineering, helping in the gas turbine design with a lot of aero engine and gas turbine customers that TCS worked with. And we were almost pioneering this in those days. I mean, if you look at mid-90s, a lot of mechanical engineering work did not happen in India as an outsourced or an offshore work here. So in that aspect, we did a lot of good work in the gas turbine space. And that also helped me understand the depth of the consulting business, how it works. Even though there was a bit of software, these were built to help develop the mechanical design aspect. So the software were driving the design process and helping automate those design process. And since this was, you would know those days it was hard for any Indian company to get good engineering work out of US, right? I mean, people still were looking at us as low-cost outsourcing force. But this group in TCS was a little different, and it also helped understand the real on the ground challenges, because fresh out of college, you have some idea about how gas turbines work or how things are, theoretically possible. But once you start working on it, you really know even a small nut or a bolt plays a huge role. And if you don't design it well, there are huge ramifications down the line. A good part of that experience was early on, I was given a lot of responsibilities by my manager that time. And that also helped me really get into the customer interactions, get into understanding what are the real pain points and how we would want to do. There was some amount of leadership trust that was put in right up front. So I would say that was one of the pivotal things that happened in my career and helped me grow really fast early on in my career. After that, I moved on to Altair Engineering, who you already know would be sort of the gold standard in the simulation software that they bring to the market. Their HyperWorks is extremely popular and very highly prevalent in the market. And when I joined, we were starting to work on engineering services or engineering simulation as an offering for several of the automotive companies globally. So it was almost like a startup because it was still new in the engineering space. And what I learned in the TCS journey helped me connect with the customers, connect with this. The Altair Engineering is a global company, so we operated through the global outpost, and through them connected with the big automotive customers globally. So that helped us really set it up in terms of building an engineering services company. We also sort of pioneered again in the area of high-end simulation. When I say high-end simulation, these could be doing full vehicle crash simulations or doing full vehicle understanding the structural stability of the cars or understanding the noise, vibration, and harshness of full vehicles. So these were not done here for multiple reasons. One being the availability of software. With Altair Engineering, the software was available to us on a platter. Along with it, the biggest difficulty was the hardware availability, because those days supercomputing was not the norm. And many of the activities that we required required a lot of high power computing, which we could use with our mothership in the US. So that helped us bring in an overall high-end bouquet offering to our customers. In the early 2000s or 2001 and thereafter, we looked at building a full vehicle capability. When I say full vehicle capability, is the ability to do creative design, which is the styling and related aspects, engineering design and the evaluation, design for manufacturability, and then build prototypes. That was our vision when we started Axiom Consulting. It's a challenging story for us, given we spun out and started around 2001. We had pitched it to several VCs. We indeed had a term sheet for close to 2 million when we had this idea and got it fructified. However, post 9/11, the VC pulled out because of the conditions that were not the best for the VCs to put in money. Everybody froze, and so did our VC. And pretty much was a bootstrap journey from there on. First couple of years, as you would imagine, doing work in this high-end space was extremely tough in terms of pulling in the resources, bringing in. We worked a lot with several universities in collaboration so that we could use their firepower in terms of the computing and the software, and built it up to some level in the first 2 to 3 years, which started propelling more business as we grew forward. Yeah, fortunately, 20 years later, we're still in business and continuing, which in the first 2 years did not seem possible. So that was the overall outline of the journey. Yeah, I'll talk about what we are doing and in future a little later.
Yeah, sure. Well, I think technically you're a second generation entrepreneur, right?
Correct.
From a family.
It is.
Sense. Your
Yes.
Yeah,
my father and uncle had a two-wheeler repair outfit. which I mean, I learned a lot of engineering doing my summer work there. I would say I learned more about automotive engineering there than in my MTech classes.
Right. So perhaps that kind of helped you even when the investor backed out, and you, for you perhaps to move forward,
Correct.
bootstrap model.
Absolutely, absolutely. And fortunately, the co-founders were also of the same mental bandwidth in terms of uh, can we, I mean, not take salary for X amount of time, right? Which is one of the primary things when you choose to go the bootstrap route. We knew it's not going to be easy for at least 6-8 months till the business picks up. And a good thing was we had few customers who believed in us, even though we were a bunch of people. I mean, we were not even a well-established outfit, right? Even though we came from diverse backgrounds, which were boasting of 10 plus years of experience at that point in time. Uh, People backed us to help realize what they were looking at. And that sort of helped early on. Uh, Even with that, it was a hard journey. Yes, I agree with you. And what we had seen the frugal living so far growing up did help. It did definitely help.
Yeah. Today, how do you see that today? You mentor startups, right?
Yeah.
So, how do you see the today's entrepreneurs mindset?
Yeah, I do hear about people who have a lot of ideas. Uh, they want funding to get the idea started. Fortunately, with the teams that I've been working with, there has been less of that. I have had a couple of people who say I can't move forward till the funding is available, right? So they're not tuned towards creating something out of whatever they have around it, right? So that's what we did. I mean, whatever resources that was available to us was what we used to get the first brick out in order to build something. So fortunately, few of the startups that I worked with also had the similar mindset. They wanted to do something, and they were asking me questions around how do we go about doing it, even though I don't have uh, a lot of funding. Many of them were self-funded. Some of them were grants that were in place, which I mean, it's not a lot of money, but money enough to help build whether it's a prototype or a business, and not to take a salary that they could. I mean, it's not a fancy salary, right? It's
Right.
more a sustenance
That's
than a
correct.
salary.
Well, see, in your journey, you come from a technical background. You're more like a technopreneur, if you will, right? And
Yeah.
so your co-founders had the sales background. How is it? Because
Yes, absolutely. We were 5 co-founders in all. Uh, uh, One of them was from deep software development background. So I work very closely with him because a lot of ideas we co-develop. I have some software development experience, but he is from deep software development experience from mechanical side. So it works. We complement each other really well. Apart from that, the other 3, one of them is very good on the operations side in terms of keeping the whole ship running, uh, uh, focusing on the financial goals and uh, getting the whole thing, I mean, still up and running, right? You have to pay salaries, you have to ensure that people are happy working here. All the aspects are taken care by the operation. And the other 2 had a lot of sales experience. So one very strong domestically and in Southeast Asia. The other person was strong in North America and Europe. So it sort of covered the entire gamut of what our operations require.
Yeah, I think that's very key even for any venture to sustain, right? Because most times two people, also majority of the time, two people get started, and most times they work together, so they bring even very similar skills rather than complementary skills to the play.
Correct, correct. Yeah.
And one more thing you mentioned about one of your co-founders coming from an operations background. I think
Yeah.
that is one area which gets so ignored, right?
Yeah,
Most
yeah,
times,
yeah,
people don't realize that you need a engine that makes it run. So you
yeah,
will always have somebody throwing light ahead for future.
yeah,
And you will also find somebody even bringing fuel from a point of customers. But if somebody
yeah,
doesn't keep that engine running
yeah.
and balancing,
Absolutely, absolutely. Yeah, even on a daily basis, we have to put food on the table, right? I mean, things have to run seamlessly. So that is a very crucial. It's a crucial role, I would say, because it also helps us to look forward and not worry about uh, things on a daily basis. Otherwise, it becomes a real mess. And the point that you make about similarity in the background of the co-founders, I have experienced quite a few when I mentor, and the cases that you talked about where people are working together, they spin out and start something, is fairly common today, and that does not help a lot. Uh, I would advise somebody uh, to really scout for a co-founder on skills and capabilities that they don't have. Really put in time in building that, whether it's operation sales or any other function that someone does not have should be the primary criteria for the co-founder rather than I like someone and I like working with someone. Uh, and hence we started, right?
yeah, that's so true. Chandra, you have been working with simulations in the simulation space and worked with a whole lot of tools. Perhaps
Yeah,
one of the earliest.
yeah,
It's from India point of view. So
correct.
how do you see the whole evolution of this space from a point of technology and also from a point of customers' expectations,
Okay.
right?
Yeah, that's a
From the time you started to today, how has things changed?
yeah, that's a very good question. I'll talk about the technology change to start with, and then I'll talk about what the customers were, how they interacted with the technology and with us as well. Yeah, if you look at the software simulation that we use, it works on a core principle or a mathematical technique called finite element analysis. Uh, what it essentially does is, if you look at a structure or a machine or a car, it's broken down into millions of smaller pieces, and you calculate if you're looking at uh, stress or strain or any other structural number. Let's say I'm trying to crash the car against the wall. I'm trying to find out how the damage is progressing through the vehicle, right? So I calculate the stress at each of the points and then uh, uh, tie it all together to understand what's happening to the vehicle. So, as you could imagine, the number of points that I break down in the vehicle is directly impacting the number of computations that the software has to do. Early on, the computing power that was available to us was extremely small. I mean, compared to today and what we had in 1990, there is no comparison. I mean, it was so small that we had to really look at uh, a big chunk breakdowns and look at like a few thousand elements, as it's called, uh, to represent any structure that we had to work with. And it was uh, ex extremely limited by the hardware that we had. And the second point is the hardware that was required for solving all of this were proprietary Unix hardware. So the softwares were built because those days Fortran was the tool of choice for scientific computing, and these used to work on specific hardware like Silicon Graphics had machines, and you had to use those machines. And DEC, which is now, which was bought by Compaq, which was bought by HP later, was another Unix platform that all these softwares worked on. What that made it challenging for folks in India were these had to be imported because those were not available as off the shelf by, I'm talking about 90s. It had to be imported, and even the softwares had to work on it, right? So the choice became really limited on how much you can solve on. And it those were the days where we used to run 2 or 3 shifts in order to make use of the investment that was done on the machine, right? So because the hardware and software are so expensive that the human cost was extremely small. So you had to work 3 shifts to cover the entire this thing, the cost that you put on the hardware and software. And since the discretization, as it's called, the breakdown of the structure into pieces, was small, people would not get very reliable results. You would get it, but still not very reliable. So people combined this along with physical testing. The reason why simulation existed or was popular is because it's trying to replace some amount of physical testing. Because to give you a perspective, you may spend $1 million to crash test a vehicle. The reason being you have to hand build a car because it's not a production vehicle. You have to pretty much hand build the vehicle. The cost of instrumentation is extremely expensive. You have to put a lot of sensors, accelerometers all along the vehicle to pick up the behavior. And you're not getting at all points of the structure. So it's a very expensive proposition to test. And all these simulations were brought in to replace some amount of testing. Because if you look at a vehicle development journey, it would take about 10 to 12 prototypes built and tested. So you can imagine how much was being spent along the way. Even if I take out 4 or 5 of those prototypes and do a virtual simulation and then test it, it's a huge cost saving. So as we progress from mid-90s to mid-2000s or 2004-5, a lot of these applications became more mainstream. You had Windows versions of these software. You had computing also grow really fast in that 95 to 2005, those 10 years, which meant now more people could do it. Even not just the automotive majors who had those supercomputing in them, a lot of suppliers also started doing similar kind of work. So it sort of democratized the whole simulation space itself. And people started using it for more problems that they could solve, not just the unique ones, which said, okay, you need so much firepower. I had only limited computing. I'll use it only for solving ABC problems. Now people started using it for a larger number of problem sets. And what we also saw around 2005-6 is also the proliferation of these technologies into non-automotive or non-aerospace spaces. Because this was still a bastion of aero and auto companies. Because it's a very high-tech world, right? And only people who could invest were those people. Now, since it was lower cost, hardware being really faster, cheaper, plus the software working on Windows and other kind of applications really sort of went across. We had applications in consumer goods, packaged consumer goods like CPG and FMCG verticals. We had oil and gas. We had all other verticals starting to use this for their product development process. And this is where in the last 15 years, I've seen explosive growth in the use of this mathematical technology to help shrink the overall product development process, giving you significant savings in time to market, lower costs, and also look at innovation pipeline being wider and deeper, right? People used to try only one or two because I had only so much as a capability. Now, since easily available, I try out all radical ideas digitally before I commit to making it. So it also helps people to think of different ideas other than just the norm.
Right.
So those were the benefits and that's the evolution that I've seen right across from 90s to today.
Right.
And yes, future is ML. I'll talk about it as well.
Sure. And what about the customers' expectation from then to now?
Yeah. So customers' expectation was earlier, yes, you do a project for me. I read the report, but I'll still go ahead and do the test because I'm not fully convinced with the technology. That was the starting point. Some of them used it to take some decisions, but not in totality, in whole belief, because our job was to run the simulation and then present a report. Beyond that, the responsibility of signing it off still was with the chief engineer there, right? He would not put his name on the line because for him, it has to be totally fail-safe. And we also did not have the conviction it can be fail-safe because of the limitations that were there in the hardware and software. As it progressed, people started believing more because the tools also became more mature and giving believable results, right? So the customer expectations also changed, and they started expecting refined results, the results on which they can base their decisions on. Ultimately, it's a decision enabling tool, right? People see value only when you can take decisions and believe in those decisions. That part between 95 and 2005, it started becoming more and more stronger. And the customer expectation is also give me results that I can believe on. I will use that instead of physical prototype. Now, I think in a lot of the automotive companies, they have built technology to the extent that they just do one physical test in the end. So all the 12, 13 prototypes in between are all digital using this technology. And that one prototype is also to get a sign off from the government to put your car on the road. So it's more not from their believability. It's not a test to find out, it's a test to pass.
Right. And how do you see startups taking advantage? What kind of challenges or limitations do they have in using these tools from a point of building products?
Today, I see a lot of startups already aware of and are taking advantage. It's very, especially people who build physical things, like it could be a consumer. We work with people who make kitchen automation equipment. We work people who are building medical devices, which is low-cost replacement for what you get in the West. So there are many folks that we work with where, again, simulation first is the approach that we take with most of them. Some of them, surprisingly and pleasantly surprisingly, they come to us with that requirement. So they're already aware of this is the approach to take. And it helps them hits the cost as well, right? I mean, you are not building a physical prototype, and every time you build a prototype, you're spending money. You spend money only when you're fully convinced that your design works, and that can be simulated, whether the thermal performance or strength-wise is it good, or you're looking at when you ship the box from point A to point B, I've taken care of all things to help the shipment hold my product correctly. All of those aspects are evaluated right up front digitally before you commit to making anything. So there is awareness, and some of them we work with them to bring that awareness. And in today's world, there seems to be a lot more awareness in terms of going down that path?
Yeah. I do work with a lot of entrepreneurs, small and mid-sized ventures.
Yeah.
And almost all of them, all those engagements where I'm hired as an advisor or a coach to the founding, there's a good number of engagements where I forcibly terminate and come out of it, is where they want to engage me to confirm what they're saying is right.
Yeah.
Right? And the approach they're taking is right. And they need my help to back up those ideas, to package it to the investors, which is
which is not the correct thing. I mean.
Which is not the way. And that's so when you were saying that initially they would just ask you for the report, they would still do. I mean, that was a thought that was coming to me.
Correct.
I wonder that must be true even today for many of them, right? They just want to confirm their own biases.
Correct.
Rather than
I'll agree to that, because a few of them were those kind of reach outs, and you try to educate them, but a lot of times they are so convinced that they just want the conviction, and once you do simulate and show it to them, this does not work, is an eye opener for them. Till then, it's they're almost like this should work.
Probably I'll have to explore some business simulation tools to see if there are such which I can show the business model and its effectiveness.
Actually, there are some model-based simulation tools available.
I'll have to look at them. But what I generally propagate is distributed model, and
correct.
There are not too many cases to talk about it. And even in the US, it's only for last few years the stakeholder economy model has been talked about, right?
Correct.
It's
just
not fully out of the academic sense, right? It is still
but it's a very interesting space. I mean, now, and I think in the couple of years to follow, you would see a lot more traction, I guess.
Yes, I am personally involved in a few companies where we are actually doing it, even for manufacturing business itself, in employing those models. So in fact, one particular company I'm involved with, we should roll out within this year. In fact, we are in the process of appointing dealers for their products, which is in the EV space, with manufacturing done in this model, with island model. So starting off with Bangalore-based manufacturing, which will cater to South Karnataka. And then copy paste the same model, as in to identify the same manufacturing hubs for each region. Across India, so that I think it's so stupid to make everything in one factory and ship it to thousands of
them.
So the idea is just make it within that 500 kilometer radius, so that there is local business, there is local ownership, and better response time. So
very interesting space. Because traditionally it's always been a gigafactory and then ship out from there to the world, right?
No, I mean, that's what shocking for me. Even that Ola still did the same stupid thing in this time and era, which is so shocking for me. So I mean, of course, maybe I've been screaming about it for many years, but being in Bangalore, I think this has not been able to reach the ears of Ola founders. So, but it's very unfortunate the way they're looking at locking in so much of investment in those gigafactories. So, what are you doing today that you think will shape the future in a much different way and better?
Oh, good. There are some investments that we are making in terms of what we would want to be doing in future, right? Mostly in terms of, when I say investment, mostly in terms of committing teams and research time in order to build something that could be useful in future. On one front, we are seeing a lot of our work that comes our way by way of projects or programs that we work on. there are elements that are having similarity across. So instead of doing it ground up for each one of the customers, we are trying to build. It's not we are trying to. We have already done 2-3 years of work where we have taken common elements or knowledge elements for each one of them, and we have built automation tools around that. So what this automation is helping us today and will do so in future is reduce the overall development time for any new customer that comes to us. And we definitely look at shrinking their development time as well as pass on the cost benefits of doing this kind of exercise. And there are several food and large FMCG that we are working with are already on board with us in terms of developing, because the elements of those require co-creation with them, because it's their application that we are using the knowledge on. So that's been working well, and we are investing more in terms of building more automation in that area. The second process is there are, if you look at the FMCG or CPG world, there are a lot of things that happen within the factories in terms of the bottle comes from somewhere, it's sorted, it's put on the line. There are a lot of transformation that happen from the time bottle comes into the plant till it's filled, labeled, shipped out. And today it's very hard to design a bottle for all these challenges. Not to mention the shipment challenges once it's shipped out, right? What today we don't have fully is an understanding of what are the forces, pressures, temperature, humidity, all of that these packages go through in its journey. So we have built a lot of MEMS-based units, which are measurement units. We already have some in place. We are building the version 2.0 of many of these, which will be either bolted onto the packages or kept inside the bottles. There are several versions of those. The common thread is we are looking at understanding what happens to each of these packages, define the loads that each one of them go through its journey. Like with any of the design activity, unless you know what you're designing for, design is going to be half effective, right? Today or in the past, this was all done through thumb rules. It was done through somebody felt this is the load that could come on it. There was no measured data that we could work with. So that's the gap that we are addressing through the measurement modules that we have. Internally, the program is called Memoir, which is a set of, again, measurement modules to map the entire thing, journey from the plant, inside the plant, and to the customer. So there is a different set of instrument modules that are put on the trucks, put inside the packages that go on trucks to help understand the entire impact of the journey. And we also have worked with some of the e-commerce players in order to do the measurements, because today, if you look at many of the FMCG products, most of them are touching 30 or 40% of their shipments being sent through e-commerce. It's post-COVID, you are all aware, right? The D2C space and the e-commerce space has just taken off exponentially. And the challenge there is people are not fully aware of what happens in an e-commerce setup. Earlier, they would put it in a brown box, put it in a pallet, and nicely ship it out. Right now, a shampoo bottle and a book and a shoe can go together in an e-commerce shipment, and you don't know what happens to it right through the journey. So those are things that we are measuring. Again, the measurement is targeted towards fine-tuning your design. When I say fine-tuning your design, sometimes people take a factor of safety approach and make it thicker, stronger, which means that over the millions of bottles you produce, you are wasting so much more material than what's required, right? So it needs to be what's really required and not over-engineered, are also not under-engineered that the shampoo bottle will leak through the journey. Or so all of this data is the most important piece in order to enable all of this development. The third piece is we are building a lot of machine learning algorithms around this measurement to help customers enable those decisions. And this is a very critical piece, both in terms of visualization as well as the process analysis. The third part of it is again, it's a recent work and yet to work with our customers, but we have done a lot of internal research which is showing us good promise, is to use large language models like ChatGPT and others to help in the design process. What we have today is a large trove of design rules through thumb rules, through first principles. There are many documents that talk about research. So what we are trying to do is to collate all of them into a knowledge piece that could be extracted to a custom large language model. When I say custom, it's a fine-tuned model which is built on top of whether it's a ChatGPT or any other. So essentially, our initial tests are around, can I design a bottle using the knowledge that I have had over the last 80, 90 years that exists today? We made some progress there, and that's been extremely promising, I would say. So those are the 2-3 areas that we are working on, apart from several others which are smaller
Right.
trials that we are doing.
Well, I'm just curious. Do you employ any life cycle analysis in this process? Is there a customer expectation that okay, we want it to be sustainable? So, is there such a demand or expectation? Because people tend to talk, labels are there, but at this stage, from a design stage, are they employed? I mean, do you do it, or how much of demand is it there from the customer side?
Yeah, I'll talk about the demand, which is very, very high today, because if you look at all the major FMCG players, they have committed to 2030 goals, which are, I would say, which are very aspirational. They want to completely cut out virgin plastic by 2030. They're also looking at being completely biopolymer by that time, right? And that is actually trickled down into the design execution as well. The people that we work with in terms of design programs, it's very apparent today. People are trying to work with post-consumer recycled plastics. The big challenge there is the quality control of all the PCR plastics, because when it's recycled, you don't know how much of HDPE, what mix, what is the end characteristics of the bottle that you will make from those plastics.
Chandra, I just want to intervene here. See, every time we talk about sustainability, first argument is that how do I reduce plastic?
Yeah.
I mean, that seems to be, hammered down to us for some years now, right?
Yeah.
And see, this is where I was trying to see. I've been looking into it for some time now, and there are multiple life cycle analysis reports. In fact, I don't know if you noticed, I had even shared some of those things on LinkedIn.
Yeah, I've noticed in your LinkedIn post as well.
Yeah, so see, time and again, when we look at LCA, what we traditionally believe is steel is sustainable, far from it from an LCA standpoint, because it starts from mining.
If you look at total LCA, it does not.
Yeah. See, I think problem is most people in business and even the most environmentalists, right? I mean, I used to be part of many such organizations. So problem is most of our things is that start when it gets in front of our eyes. So it is in my hand, it's on my desk, and that's where the life begins. But it's not true, right? And they have already consumed future energy, if you will, right? To get to be in the form that we are holding it today.
Correct.
And people tend to say that I use it for 1 year, this steel thing, or I use it for a month, this glass bottle, whereas I can use this plastic bottle, but then it gives microplastic, which causes cancer. There is zero technical report that confirms it. But there is so much of narrative on that. So that is where that's where I wanted to know, is there an LCA approach, a complete life cycle analysis approach, or is it still that most people are narrative driven and say, come with, cut down plastic or reduce plastic? I mean, without a proper basis or looking at a complete LCA view to it.
Yeah, I don't think there is a complete LCA role in what we are interfacing with, but there are 2-3 vectors in which people seem to be operating. One vector is reduce material, which is good in any way, because if you are a good designer, you will use less material to give you the same strength that you are looking at, right? Whatever material you are using. Second is use recycled plastic as much as possible. So that's the other vector people are looking at. The third vector is to look at the product itself and look at concentrating the product. You would have seen some examples of those, wherein the detergent is delivered in a concentrate, which is like 4 times stronger, which means that a 2-liter bottle is fitted into a half-liter. Instead of pouring a huge cup of detergent into your washing machine, you would put quarter of that amount in because it's concentrated. There are several cleaning liquids that have come in concentrate forms, wherein you reuse the cleaning spray by just pouring this and topping up with water, right?
Correct.
So these are 3 or 4 vectors that we have seen as a delivery mechanisms in the world that we are operating. So that seems to be the direction. I mean, in terms of life cycle, cradle to grave and beyond, that is not something that we have been engaging with. Mostly in this 3 or 4 vectors that we work with our customers.
Yeah, but since we are talking about it, don't you see there's a huge opportunity for a business such as yours to actually approach it from before cradle to after grave, beyond grave?
Yeah.
From that approach, I think.
Yeah, it is, but we have had 1 or 2 small consulting engagements in terms of doing research to understand that space, not necessarily work in the space. That involved a lot of on-the-ground study, people going out, picking up plastic and understanding and all of those. But as a concerted effort, yes, there is definitely potential. And I would say in the next 5 years, we have not made any progress there. If we invest something in that sustainability area, I'm sure even the consulting business can grow, because the awareness for doing that has gone up multifold, as I see today.
Yeah,
that's a good point. I mean, definitely.
In fact, yesterday I was in a startup idea review for some hackathon. So one of the projects was about hydrogen.
Okay.
Right.
Okay.
And hydrogen being clean and carbon neutral, zero carbon and all that. I mean, it completely defeats the fundamental
how was hydrogen given to you is not talked about.
Yeah, no, but even hydrogen is actually contributing to creation of ammonia itself in the thing, which it is further contributing to the global warming.
Correct.
And greenhouse gases, various other things. So hydrogen is one of the key components here. So the more hydrogen you produce, and almost 30% anyway gets leaked into it. So we are actually contributing to it and then claiming it to be the cleanest. So I think there's so much of narrative at play. And the arguments are, the business pitches sound more like political pitch. And
there's already, there's a lot of push, even in India, right? Green hydrogen is the next in thing, at least in the political pitches today.
Right. For the audience and listeners, please go back and look up to our podcast with Paul Smith, where he actually talks about and explains why hydrogen doesn't work and what are
Good.
the
I'll also
limitations
check
with
out.
hydrogen. So, a
Yeah.
very interesting thing for those who want to get into that argument. And they are in three parts, so please make time and look up each of them. And also do follow him. He's a very interesting guy and keep sharing so much about this space. So, Chandra, you uh, you have been one of the earliest users of ML, right, from a point of automation.
Yeah. Yeah.
And today, of course, it's the thing again, right? I mean,
Yeah. Yeah.
everybody is talking about it. It's kind of become cool. In fact, I see so many startup pitches. They also put AI powered. How is it AI powered? But
Yeah.
it's
Yeah.
becoming
Maybe the
jargon.
presentation is AI powered.
Yeah, it's so true. Yeah, very possible. But they say that their business itself is. So, how do you see this evolution from a point of application? Because you have been one of the people who have been applying it all through your thing. So, can you give a quick evolution
Sure.
of this? Yeah.
Sure. Sure. Back in the day, we used to do a lot of work uh, from the mathematical point of view. Statistics is one of the things that we worked with quite a bit in several of the programs. So I mean, those days it was called numerical methods, where we used to multiple different approaches for doing regression. A lot of curve fitting you would do, and those were bread and butter in most of the work that was done, right? And those were simple programs that were written either in C or Fortran that you would uh, get the data and pump it through that. You would develop a little more MATLAB or Fortran programs to help run those. Uh, the big difference that I see today, even though the methods are similar, is the ability to crunch the amount of data. Those days we had extremely small amount of data, and those also would run for half an hour, 1 hour, because of the compute capability that was available to us those days, right? Uh, Today we can, given the GPU computing that are in your workstations, I mean, I'm not even talking about high performance computing, I'm talking about workstations. You can crunch huge amount of numbers today. And that's what we are seeing in our day-to-day work also. And if the data is even bigger, there's always the cloud computing that you can rely on. And most of, whether it's AWS, Azure, or Google, are elastic in nature. So you could expand the amount of space that you have. They also have inbuilt ML routines that you can use, which works very well within their own cloud data, right? So that's the big difference that I'm seeing. Those days we applied it on small niche problems and solved only those problems. Now the data that you're dealing with are extremely large, and I had several experiences of late where we have taken a lot of our customer data dating back to 1940s and 50s. Yes, 80% of the grunt work is to clean that data and put it in a CSV or a columnar data. Once you do that, the power of ML today that's available is really, I mean, big difference from the ML or numerical methods that we use. The methods may be same, but the computing firepower that you have today is significantly higher.
Yeah, and also I think digitization in practice for last 20-25 years itself
Mhm.
will make a lot of data available and accessible
Correct.
to work with, right? See,
Absolutely.
earlier I remember there was so much of effort in digitizing the very data itself.
Yes,
I
yes.
did. So today, with the last 20 odd years, so there
Yeah,
is digital data available. So,
yeah, yeah.
so
It's funny you say that. Even with that, we have struggled a lot. When I say struggled a lot, is we work with one customer or two of them across the globe. Now, simple things like fourth column of one customer stored data is eighth in the another customer data, and there's no consistency. That is one.
yeah, yeah.
Secondly, the languages are different. The same, I can't directly use keyword search to pick a particular term because the same term in Spanish is written a different way. So those were challenges. I mean, it's not unsolvable challenges, but yeah, it makes
standardization
a lot of
issues,
grunt work to get to a standardized format. Once the standard is there, what you're saying is right. I mean, you can do tons of different things, give them insights they had no clue about how it works. Several times we have had people making same kind of packages in Mexico, in North America, in Europe, or in Asia for the same type or the same product, same SKU, go through the full product development process, whereas you could have just picked the design from your Mexican counterpart and then changed the label language and reintroduced in your market. It's a huge waste of effort because we are doing it all over again, right? This centralization of that data and the single source of truth for all of them made it very easy. So you could pick a design that's working elsewhere. Working elsewhere is a key parameter, right? It has gone through multiple iterations so that there is no leak when you ship it out in the product to the market. Customer enjoys using it. So all those things you need not reinvent again. So there's something existing, just reuse it. So those were enabled through this program.
Right. So, Chandra, do you, it's always true that we always have a lot of people who influence us in our lives, right? Starting from family, friends to work and even teachers. So, are there people you want to talk about who have influenced you to say that what you are today is perhaps because of these people?
Yeah, I mean, it's hard to single out a few people because I would look at every stage of schooling. I've been fortunate to have a few teachers who, I mean, I see mostly you like a subject because you like a teacher, right? That almost is the truth from the primary school.
Rather, you are good in a subject because teacher makes it so interesting for you.
Correct, absolutely. So that has been the case both in primary and the secondary schools. In engineering as well, I've again been fortunate to have a few teachers who really instilled the foundation, made it interesting so that I pursue even masters in a field which is the thermal engineering that I did, is also because I developed interest in some of those areas. A lot of it is what I learned from my father and my uncle through their venture, and then working with them all through my summer vacations, right? Even though I mean, we played a lot, it's still the mornings were there working and learning from that. I definitely look at that. Early on in my TCS career, I had a manager named Ranga who was almost very instrumental in looking at how my career took off because the responsibilities he gave made me go in front of the customer, pitch it, even though I was very young at that point in time. So definitely one of those, and many folks in Altair that helped me grow my engineering career, and my colleagues in Axiom as well. And on the family side, yes, I mean, in the last 20 years or so, family has been a big part of support in helping me where I am today, right? I mean, a lot of slack that's there on the family front is supported. My wife has been a huge source of strength right through my journey as an entrepreneur. And she's I mean, she's a senior working professional. She, apart from being that, has been extremely, I mean, she has her own challenges on the work front on a daily basis, but has been a huge source of strength right through the journey. So some of the people that I definitely want to thank to me being where I am today. Hey, I lost your voice.
Sorry. Yeah, there are so many new subjects today, right?
Yeah.
If you were to go if you were to do engineering today, what would be the subject that you pick?
Yeah, I think mechatronics would be something that would be of most interest for me, wherein there is an interplay between mechanical, electronics, and computing.
Computer
So
science.
that, yeah, so that would be my. I still would, because I picked that up through my journey, through several experiences. But if I want to study and come up, I would definitely choose that as a subject of choice.
Right, right. In fact, that's what I probably thought. Yeah, before we close this section, you used to be a fantastic cricketer. We played cricket together. So you were
Yeah.
the fast bowler. So how is your is that still a passion? Do you still get time to play?
I
Or
used to
do you
play
make time to
till
play?
time is there. I used to play till about 14 years back, I would say. But now it's more following cricket. Yeah, back in the day, I played even for the South Zone University. So it's been, I do have friends who are in big positions within the cricket organization as well as outside. So I do catch up with them, get to know what's the latest. Because cricket, those days to today, like technology, is totally different, right? I mean,
Yeah.
yeah,
So
what we were,
do you wish you were a cricketer today? Because
absolutely,
you could have probably
absolutely.
been a professional cricketer. What would you have done if you were to be playing cricket today? Or maybe even
Yeah,
not today, even say 10, 15 years ago when the IPL got started, right?
yeah,
If you
I
were
would
to be,
definitely,
you would have been an
yeah,
engineer or you would have been a cricketer. What would be your
I
choice?
would have focused more on cricket, I would say. The fun part is my family was pushing me to study, like any other middle class South Bangalore setup. It's only when I joined engineering I took cricket a little more seriously because I had freedom to do so. Uh, the My parents were not saying anything because I already got into engineering and there was no uh,
Right.
uh, yeah. So yeah, I would have probably started a lot earlier eh, given today, because even my parents would have seen that could be a career option, right? Those days it was not so. Uh, so yeah, probably would have started earlier. And all things that our coaches said don't do are the things that are done today. So I would have probably been better off today than those days.
Right. So it looks like cricket is still your first love.
Yeah, absolutely. No question about
All right. Wonderful. Do you make time to read still? Do you read? And what kind of things do you read?
I do read sometimes, not as much as like 10, 15 years back, because those days I used to travel also far more. So during the travel time, you have to kill time, right? So you would read quite a bit. Uh, I mean, just generally the business books are the ones that I read. Of late, in the last, I would say 2, 3 years, I do a lot of audiobooks. So the audiobooks are a really good way of, I mean, it's not as good as reading, but at least gives you,
Oh no, for me it's completely audiobooks. I
yeah,
actually read just 3 books in a year or so because one, it could be in Kannada, and two, maybe authored by friends, and
mhm.
they are not available on audiobook, so you need to read and give feedback.
Yeah, yeah.
So otherwise,
So
it's
yeah,
all audiobooks.
yeah, audiobooks are a lot of podcasts are there like yours. I also follow like there's one called Twimmel, which is the machine learning podcast. There's very interesting one, Future Farming, which is about uh, typically about automation in farming. I've sort of developed interest in that podcast after listening to one or two of them. So I do like that. And books, generally business books. The one that I read as well as followed up again with the audiobook was the Flipkart story. I think it's called The Big Billion Startup or
Correct.
something like
Correct.
that. Yeah. So that was interesting enough to do twice, one on the book and one on the audiobook.
Oh, for me, it was only a audiobook story. Yeah, because there's so much to listen to.
Yeah, absolutely.
I don't remember having gone back to another book because
Yeah.
already
Yeah.
what is left to catch up are so much more.
Yeah, the Audible itself, I mean, backlogged by 4 or 5 books because every month you get a credit, right? So I've not used up to like 4 or 5. I still have, which I can borrow from Audible.
Yeah, I know. I consume quite a bit that way. Right.
Oh, nice.
Yeah, almost 3-4 books a month. It becomes
Yeah, that's
on Audible, of
good.
course.
Yeah. Yeah, you can do, I mean, driving, walking, anytime you can listen to, right? So,
Actually, yeah,
mhm.
I'll commute mostly
Yeah,
Audible.
yeah.
If I'm in public transport noisy, I shift to music because
Okay.
you don't have to concentrate so much when
Yeah,
it's noise. So music is
yeah.
the second preference, right?
Okay.
So good, Chandra. Thank you so much, and for the listeners and audience, I hope you enjoyed this conversation. Do come back soon and do share this across. And come back soon because we're going to bring Chandra in to talk about what's happening at his work front and how are things taking shape and his perspective on what is risk and opportunities that he sees in these. So do come back and do share. And those of you who have not yet subscribed to Future Path, do it right now. Once again, Chandra, thank you so much.
Thank you, Nanjunda. Hope it was interesting conversation.
Well, I'm sure, and also for the audience and listeners, the links are there below to follow Chandra and his work, and also you can reach out to him. So please do follow there. Thank you.
Thank you. Thank you.